In this example, we have the function 1 over x, and we want to find the simplified form of the difference quotient here. This is a really good example for understanding just the algebra behind this whole process. So we have the difference quotient, f of x plus h minus f of x all over h, where h cannot equal 0. So we want to take x plus h and plug it in wherever we see an x. So in this one, we have 1 over x. So all I'm going to have is 1 over x plus h. I'm just replacing, I know it's weird because it's 1 over x. So you think, what does that become? You just replace the x. It's no different than any other problem, like x squared, x to the third, no different. It's just x plus h goes in for x. So we have 1 over x plus h. That is the f of x plus h. Minus the function, minus the f of x. So that would be minus 1 over x all over h. So before we even deal with this h here, we really have to deal with the top. And where do we go from here? So we have 1 over x plus h minus 1 over x. What we want to do is we want to find a least common denominator. So I have x plus h here, I have x. So it looks like I could just multiply this one by x, this one by x plus h, and then we have the same denominators, and then we'll just have some algebra to do and some simplifying. So let's check that out. So I'm going to multiply this one by x, and I'm not going to actually multiply this through. We'll just leave it as x times x plus h. I'm going to multiply the top by x. Whatever I do to the bottom, I do to the top. And here, I'm going to multiply by x plus h. Whatever I do to the bottom, I do to the top. So x plus h. So what does that look like? That is going to be x times 1 is x minus 1 times x plus h is going to be x plus h all over x times x plus h all over h still. We could probably just ignore that h for a little bit. We're really not going to deal with it until we deal with all of this craziness on top here. From here, I want to distribute the minus. So we're going to have x minus x, because I'm doing negative 1 times x. Negative 1 times h is negative h all over x times x plus h all over h. What happens next? 1x minus 1x is 0. So the x's are out of the picture now. That's zeroed out. That's pretty cool. That might help us out. So let's see. Now we're just going to be left with negative h on top over x times x plus h all over h. Now we're kind of at a moment where, all right, I took care of that. That was pretty fun. Now I have to move forward with this process. So I have this fraction being divided by h. Now remember, it's divided by h over 1. So if we're dividing by h over 1, what we're really doing is we can multiply by 1 over h. So then we're left with negative h over x times x plus h times 1 over h. And look at this. H, gone, cancel out. So all we're left with then is negative 1 over x times x plus h. That would be the simplified form of the difference quotient. This problem really gives people fits for some reason. I think it's just the more visual of it. It's weird that we have this fraction over a fraction, and then you got to do some least common denominator and add, subtract. It just gets a little messy and scary. But if you just approach it problem as a scenario by scenario, just look at this all right, I'm going to ignore that h and I'm going to go through this process. I'm going to try to simplify as much as possible, and there's a couple steps of simplifying, and then we get down to here where then you got to think, what am I really doing here? If I'm dividing, I can multiply by the reciprocal. Oh, awesome, that takes care of the h's, and then I'm just left with this. So don't let something like this intimidate you. Just start to piece things together and start to go through it, and it'll just start to click as you go through it, and just the process seems pretty natural from there.